Hello everyone, so this will be complex numbers tutorial part 2. Part 1 discussed just the basics of complex numbers, what they are, how to form them in rectangular and polar form. I recommend that you watch that video before watching this video. I'll put the link for that part 1 in the description. So the part 2, I want to talk about how we add and subtract complex numbers and also how we multiply and divide complex numbers. So let's say that we have two complex numbers, and let's say that they are in rectangular form. So let's say the first complex number is 2 plus j3, and the second one is 4 minus j7. If they're in rectangular form, adding and subtracting, this is the best case scenario. Rectangular form is the easiest form to add and subtract. So let's say we're going to add them. z1 plus z2. You literally just add the real parts and add the imaginary parts, and that's it. So let's just plug it in here. So you add the real parts, so you just get 6 here, and the imaginary parts here, you're going to get, right, because 3 minus 7, you get a negative 4, so you're going to get negative j4. Now, remember, when you're working with the imaginary parts, you want to make sure that you don't forget the j, okay? So that's it for adding. It's very simple. What about subtracting? Same business, except now you're subtracting. So we have z1 minus z2. Here's z1. Okay, you can open up the parentheses over here if you'd like. That way it makes it a little bit easier on the eyes. That minus sign is going to infiltrate, so you get here minus 4, and then the minus j7 is going to become positive j7, so this will become a little bit easier to work with if you open those parentheses. So here we're going to get, as you expect, minus 2 plus j10. That's it. Okay, very straightforward, very easy. Now, the challenge comes when you have complex numbers that are in polar form and you are asked to add or subtract them. That becomes more of a challenge. So now the next part is adding and subtracting complex numbers in polar form. So let's say that we're given two complex numbers, again, in polar form. Let's say the first one is 4 at an angle of 45, and the second one is 3 at an angle of minus 30. Okay, what you're going to need to do is you're going to need to convert these into rectangular form and then add and subtract them. So let's put this guy here. Okay, so convert to rectangular form, and then add or subtract normally. So let's do that. So let's start with the first one. To convert this into rectangular form, if you don't remember, it is also in the part 1 video, but in case you forgot, you take the magnitude of the complex number, which in this case is the 4, okay? The real part of, the rectangular form, it's going to be 4, which is your magnitude, times cosine of this angle. So in this case, it's cosine 45 degrees. The imaginary part, you put plus j, and again, you take the magnitude, which is the 4, and now you multiply by sine of the phase angle. Okay? Make sure that when you're doing these calculations that your calculator is in degree mode. If it's in radian mode, everything will be wrong. So please make sure it's in degrees. So when you work this out, you're going to get that the real part of this complex number z1 is 2.828, and your imaginary part will be 2.828. Okay, the reason they're the same, it has to do with the fact that I happen to choose 45 degrees as the angle. Okay, so that's your z1 in rectangular form. Again, Z2 is the same thing, so let's just write it first like this in polar form. All right, and let's work it out. So it's 3 times cosine of the phase angle, which in this case is minus 30. And then you're going to have 3 times sine of the phase angle, like so. When you work that out, you should get, for the real part, 2.598. And the imaginary part, you're going to get a negative. It's going to be minus j 1.5. So now you have these guys in rectangular form, and the addition and the subtraction becomes very easy. Okay, it's just like we did before. So let's add them now. Okay, I'm just going to give the answer. You can check the answer yourselves. By the way, I round off the decimals. I don't put all the decimals, and it depending on where you round off the decimals, you may get some round off error. Just wanted to make sure you keep that in mind. So adding them together, we add the real parts. If you add the real parts, you're going to get 5.426. Again, that's if you add this and this. Right now, we're going to add the imaginary parts to get the imaginary sum. And it's going to be here 1.328. All right. You're going to now practice the subtraction. All right. You subtract the real parts. And when you do that, you should get something like 0.23. And you subtract the imaginary parts, and you'll get something like this. You'll get 4.328. Okay. When you subtract the imaginary parts, right, this one who's a negative is going to become positive because minus minus. So you get that. And that's how you do it. There you go. Now let's talk about multiplying and dividing complex numbers, okay? Let's say that you're given numbers in polar form and you're asked to multiply and divide. This is the best case scenario if you're multiplying and dividing. Polar form is the best case scenario for multiplying and dividing because it becomes very easy. So let's take an example. Let's actually use the same complex numbers, these ones, in polar form. Okay, and then Z2 was this one, 3 at an angle of minus 30. All right. So if you multiply, let's say multiplying. So Z1 times Z2, okay. Basically what you're going to do is you're going to multiply the magnitudes. You're going to multiply the magnitudes, and you're going to add the phase angles. Okay, so I'll say it one more time. You're going to multiply the magnitudes, and then you're going to add the phase angles. So 4 times 3 is 12. All right. And then the resultant phase angle is going to be the sum of 45 plus negative 30. So that's just going to be 15 degrees. Very easy. Not subtract, divide. My brain was one step ahead of my pen. Okay. You'll see now that when we divide, if we were adding the phase angles when we're multiplying, imagine what we're going to do when we're dividing, right? We're going to subtract. Okay. So basically, to divide the complex numbers, what you do is you divide the magnitudes, and then you subtract the angles. Okay. So 4 over 3, it's going to be repeating 1.33. Let's leave it like that. And when you subtract 45 minus negative 30, you get here 75 degrees. And there you go. So that's the best case scenario. Now, of course, what happens if they're in rectangular form and you're asked to multiply them? Well, then you have to do an extra step. You have to convert it from rectangular into polar and then multiply or divide them. So let's use the very first example. We'll use the complex numbers from the very first example. So z1 was 2 plus j3. z2 was 4 minus j7. Okay, so what you're going to have to do, you're going to have to take these guys, convert to polar form, and then multiply or divide. All right. This process, I wouldn't say it's more difficult. Just have to, it may look a little bit more difficult, but it's really not. So let's practice. So here's z1. And I want to convert that into polar form. So basically what I have to do to convert it into polar form, I take my real part. So I have to find two things for polar form. Number one, the magnitude. Number two, phase angle. So let's talk about how to find the magnitude. So to find the magnitude, you take the real part, you square it, you add it to the imaginary part, you square it, and then you take the square root of that sum. Now let's talk about the phase angle. To find the phase angle, you have to do the inverse tangent, arctangent, whatever you want to call it, okay, of imaginary part over the real part. Imaginary over the real part. All right? And when you punch the numbers in, you get this. Let's do the second one. So here we have 4 minus j7. So again, you're going to take the real part, square it, add it to the imaginary part squared, take the square root of that sum. That's your magnitude. And your phase angle is going to be the inverse tangent of the imaginary part over the real part. And in this case, you will get something like 8.062 at an angle of minus 60.26. And now you're ready to rock and roll. Multiplying and dividing now, it's very easy. So if you multiply them, you should get something like this, 29.07 at an angle of minus 3.95 degrees. If you divide these two numbers, you should get something like this. .447 at an angle of 116.57. Let me just fix this minus sign so it's not confusing. I want it to be very clear. Minus sign. All right. Okay, so essentially with enough practice, this will become much easier. At first, it might seem a little bit strange, but again, with practice, it'll become second nature. Let's try one final example, and let's say that we have something like this. Okay, we're asked to find out what is the result here. So here we have polar form, we have a mix, and then also we have technically this is rectangular form, right? So we have a mix of not only multiplication and subtraction, but we also have a mix of polar form and rectangular form. So how would we do this one? Basically, you have to combine everything that you learned in the first part of this video. So let's do it together. So first, what I would do is I try to divide and conquer. So I try to start with the simplest thing that I can do, the simplest simplification I can make, and then sort of go from there. So for me, this of course comes with experience, and with time you'll start to see this as well. For me, this is sort of the easiest thing to start with. Okay, whenever you have a complex number, it's just j. In other words, there's no real part. So basically, this complex number could be written like this: 0 plus j49. And oftentimes we'll just omit the real part because the real part is 0. So it's just J49. J translates to angle 90 degrees. Okay, J means angle 90. So if you're just given something like this, okay, the magnitude is going to be 49 and your phase angle will be 90 degrees. Okay, so immediately this I would convert into polar form immediately. If it's a minus J, obviously minus 90. Okay, so that's the first thing I would do straight away. So here we go. 49 at an angle of 90. All right. Obviously, you have to follow order of operations. That also is important. In this case here, we have a multiplication, right? And in this case, we have the best case scenario. They're both in polar form, so the multiplication becomes quite simple. We just have to multiply the magnitudes and then add the phase angles. So if we multiply the magnitudes, we should get something like 7,938. When we add the phase angles, we'll get 123 degrees. I'm going to leave, so this guy we haven't done anything yet. Let's just leave it here for now. Okay. Now we kind of have not so good a scenario because we have to subtract, but these guys are in polar form. So we have to convert it into rectangular. Both of them we have to convert to rectangular form. So this one is it's sort of like a corollary to this shortcut for the J. Okay, if it's just a number, angle 0, it means that this is just a real number. There's no imaginary part to it. So if the angle is 0, in a way, you just write the magnitude. Let's say you don't believe me, and you want to actually convert it, and that's fine, right? Check it out. You would have the real part as cosine 0, and then you would get the imaginary part with sine 0, right? And you'll see that the part with the sine goes away, so you just have the real part. Okay. This one, you're going to have, this one you have to do it. There's no way around it. So it's cosine of 123 degrees. And then here we're going to have the sine, we have the J, sine, it's not going to fit. It's not going to fit, but we can force it to fit. Okay, we'll make it fit. Okay. There you go. All right. So obviously the sine 0 part, right, that's going to be 0, so there's no imaginary part for that. For this guy, there's no imaginary part. It's just the real part, and cosine of 0 is just 1. So we're left with 1,3,200 there. If we work out the calculations here with the 7,938 times cosine 123, we're going to get negative 4323.3. Okay. The imaginary part is going to turn out to be 6657.4. All right. We can open up the brackets, and then we can allow the minus sign to infiltrate in there. So that negative 4,323, right? That's going to be positive now. And then the imaginary part, we're going to get a negative. And basically, we're one step away from the solution. The real part here, you add it to the real part here. So you end up with this. Well, this is the full real part, 17523.3. And your imaginary part, this thing moved on me, okay, is this. So there you go. Now, of course, you could take it one step further and convert this into polar form. So converting it into polar form, you'll get something like this. Now, you don't have to convert it into polar form unless you're asked to, but I just thought I'd add this here as one more little exercise to send you all home with, to check it out, see if it works, okay? And you'll see that it should work, okay? And that's complex numbers tutorial part 2. Thank you.